Okay, so in this video, we're going to look at proportion questions. A proportion tells you how many times bigger or how many times smaller one item is compared to another. An example of where we will see proportion used is when it comes to recipes. Here we have a sample question. Here is a recipe for scones. Scones serves 8, butter 60 grams, flour 260 grams, baking powder 2 teaspoons, buttermilk 180 mils. How much of each ingredient would be needed to make scones for 2 people? Okay, now, the first thing I'm going to record up above here is the important information. Perhaps underline it. So, butter 60 grams is important, flour 260 grams. Again, information I want to be aware of. Baking powder 2 teaspoons, and buttermilk 180 mils. Okay, the next thing I need to identify is that this indeed is a proportion question. So what I'm going to write down is how much each serves. So the ingredients above serves 8 people. Okay, so if it serves 8 people, and then I've also been told that we now need to look for the amount of ingredients necessary to serve 2 people, then I ask myself, proportionally, what's the difference between 8 and 2? And when I think in terms of proportion, I always have to think in terms of either multiply or divide. Something is a certain amount of times bigger or times smaller. So therefore, I'm always thinking about either multiply or divide. So what do I do to an 8 to turn it into a 2? Well, the more observant mathematicians of you will have easily worked out that you divide it by 4. So if that's the proportion we're dealing with, then I need to divide all the ingredients by 4 up above. And that then is just a question of you going and doing those math calculations, and it should be pretty easy. However, one that might be a little tricky is the 2 teaspoons, because you're going to end up with a decimal. You should end up with 0.5 of a teaspoon or half a teaspoon. The rest should be pretty straightforward. Okay, let's look at a slightly more challenging proportion question. Here it is. In this question, hopefully you can see it okay. It says, here are 2 plastic bags of £1 coins. £1 is the currency used in the UK. So it says the first bag has a weight or a mass of 190 grams. Second bag has a mass of 123.5 grams. The first bag contains 20 £1 coins. How many £1 coins does the second bag contain? Okay, now again, there's a few key steps I would recommend. The first one would always be underline the key information. So the key information here would be there's 2 plastic bags. There is a first bag, which contains 190 grams. It also tells me that the first bag contains 20 coins. There's actually physically 20 £1 coins in there. Second bag has a mass of 123.5 grams. We don't know how many coins are in the second bag. We've got to work that out. So my suggestion as to how I would solve this here is I would try and record the information, first of all, as a word. So I'm looking for coins, and I'm looking for mass or weight. So we'll call it mass, is the more correct term. So I'm looking for the coins and the mass. Now, for the first bag, it tells me that there are 20 coins, and it tells me that gives me a mass of 190 grams. So I think the first thing I might do then is plot that information. Now, because this is a proportion question, I should know that the amount of coins to the mass of the second bag should be similar or should be proportionally the same. It tells us the weight of the second bag to be 123.5. However, we do not know how many coins are in that bag, and that's what we have to solve. There's 2 very obvious ways that I see as to how we could solve this question. I'm going to show you both. The first way might be the way that many people go. I'll use green tool here. I'll work out how many coins, how much would one coin weigh? That's what I'm going to work out. I'm going to work out how much would one coin weigh. I know that 20 coins equals 190 because it tells me that information. So now what I'm going to work out is how much would one coin weigh? Well, the way to calculate that is I will have to divide 20 into 190. So I'll go about doing that now. I'll do it over here in the long division. 20 divided into 190. And I start off again. Hopefully you remember the dad, mom, sister, brother method. Does 20 divide into 1? No. Does 20 divide into 19? No. Does 20 divide into 190? Yes, it divides in 9 times. 9 times 20 is 180. Subtract. I have 10 remaining. I'm going to move these out of the way here temporarily. Move the brother up here. Speaking of brother, I'm going to actually extend this calculation, put in an extra 0 and bring it down. This number now becomes 100. Does 20 divide into 100? Yes. How many times? 5 times. 5 20s are exactly 100. Subtract, no remainders. Now I've worked out that one coin weighs 9.5 grams. So one coin weighs 9.5 grams. I've been given the weight of bag 2. Tells me bag 2 weighs 123.5. So all that remains to be done now is to form my number sentence. So my number sentence should be, for bag 2, it should be 123 divided by 9.5, and that should tell me how many coins are in that bag. So I'll go ahead and do that. I'll put my 9.5 here. Actually, what I might even do here is I might adjust both the numbers. I might move the decimal from the 9.5 over to one place to the right to convert that number to 95. Similarly, I might convert or move the decimal one place to the right on 123.5 to make it 1,235. And it should give me the same quotient by the time I've completed my calculations. 95 does not divide into 1, does not divide into 12, divides once into 123. I subtract my 95 from that number. 5 from 3 I cannot do, so I borrow from next door. 13 subtract 5 leaves me 8. 9 take away 9 from 1 we can't do, so again we borrow from the neighbor next door and becomes 11. 11 subtract 9 is 2. So now we have 28. 95 does not divide into 28, so I'm going to obviously bring down my 5. 95 divides into 285 exactly 3 times. We do our subtraction to prove we have no remainder. And we see our answer up above then shows us now that bag 2 would indeed have 13 coins. So I would write that as a full sentence. The other way, interestingly, that we could do this is known as the cross-multiply method. So we could plot our information. Again, I'm just going to remind myself what we understand, what we know. We know that 20 over 90, and what I might do is just copy this equation here. Copy this entire equation. I'll rewrite it at the bottom of my screen. Drag it down here. Okay. Now, in the cross-multiply method, what we need to do is we need to literally multiply the diagonals. In this case, what that would mean would be, after you do that step, you would end up with 190. Now I'm going to give the question mark, maybe I'll give it an actual symbol. I'll refer to it as the letter Z here. So 190Z equals 20 times 123.5. So again, what we need to do now is we need to solve Z on its own. So you want to get rid of that 190. The way to do so is to divide both sides by 190. That will cancel each other out on this side. And over here, you will have this calculation. You would do your multiply first. You would do your 20 times 123.5, whatever answer you get, divided by the 190. And you would end up seeing that Z or Z here equals 13 again. So there's two methods. You can choose whichever one you prefer.